Good afternoon to all of you, ladies and gentlemen. Towards the end of February, I presented a face-to-face training workshop to you on how to apply the visualization and symbolization teaching approach for the 2 grade 11 mathematics topics, equations, functions, and graphs that are earmarked in this research project. And after the workshop, I also shared with you a video presentation on examples under the 2 topics whose solutions were determined using this visualization and symbolization approach. I then asked you to go back to your schools and apply this teaching approach to your grade 11 mathematics classes for the 2 topics, which is the program that is currently underway. And I've moved around some of your schools to conduct some lesson observations, and the feedback I'm getting from you is that everything is running smoothly. If you remember, during the first workshop, I indicated to you that this visualization and symbolization teaching approach can be applied to almost any topic in the mathematics curriculum, not only the FET phase, but all phases from primary right up to secondary. And because you last time indicated to me that most of you are also teaching grade 12 classes, I promised that during the first week of March, I will conduct a second workshop on grade 12 mathematics topics using this visualization and symbolization approach. And the topics that I identified are the remainder theorem, cubic functions, and graphs. Again, my name is Themba Munene. I'll be your host for this workshop presentation. We're going to begin our presentation by discussing examples of questions under remainder theorem, where analytic thinking and visual symbolic thinking strategies can be applied in solving problems in the mathematics classroom. Before we look at the examples, let us discuss briefly what is the remainder theorem. It states that when a polynomial f of x is divided by x minus a, the remainder r is equal to f of a. And if f of a is equal to 0, then x minus a is a factor of f of x. Let us look at an example. During the previous workshop, we ended at example 3. So we call this example 4, which reads, given that f of x is equal to x cubed minus 3x squared minus 13x plus 15, show that x minus 1 is a factor of f of x. Therefore, factorize f of x complete. We are going to look at the solution to that using analytic method. The first method is long division. 4.1, to show x minus 1 is a factor, we take this x minus 1 and equate it to 0. When you take the minus 1 across, and cosine, you get x is equal to 1. So we substitute x is equal to 1 in the function. We get f of 1 is equal to 1 cubed minus 3 times 1 squared minus 13 times 1 plus 15. If you evaluate this in your calculator, you will find that it is equal to 0. And therefore, from the remainder theorem, x minus 1 is a factor of f of x. 4.2, we're going to use long division. We found x minus 1 is a factor, and we are going to divide this x minus 1 into the expression of the function. We are all familiar with this long division method because you use it when you are introducing factorization of quadratic functions or cubic functions. So I'm not going to discuss this in detail. What happens is here with long division, you go through these steps where when at the end you subtract the terms that are corresponding, you end up with a 0. And the other factor will be the answer that you get. What this means is that when you multiply x minus 1 with x squared minus 2x minus 15, you will get the function. And therefore, we now look at this quadratic expression and factorize it further. Here we are using the grouping method to determine the factors as x minus 5 times x plus 3. So that our f of x, which is equal to, from the long division, x minus 1 times this quadratic expression, will now be equal to that when you replace the expression with its factors. So f of x is equal to x minus 1 times x minus 5 times x plus. This is the answer to 4.2 using the long division method. Right. They are also other analytic thinking method. The other analytic methods that can be applied are the second one, using the inspection method, or the third method, C, using the synthetic method. I'm not going to discuss these ones because we are all familiar with this. And we are going to discuss them in the next example. What I want to introduce now is a fourth method. So we have discussed 3 analytic methods. The fourth method is using the visual symbolic method, which you can call method T. I would like okay, with 4.1, we also go through the same steps. Showing x minus 1 is a factor. You look for f of 1, go to 0, then therefore x minus 1 is a factor of f of x. When it comes to the factorization of f of x, using the visual symbolic method, this is how the thinking process goes through the mind of the problem solver. In other words, it is the visual symbolic thinking process which goes through this observer as he or she looks at the parameters in the function and manipulates them in the mind to actually determine the factors using a shorter method or in a few steps. So this step here, I'm going to explain it like this. Imagine we don't know the terms in the second bracket. What will happen is, because we have found that x minus 1 is a factor, we will write our first bracket x minus 1 in the second bracket to determine the terms in that second bracket. What you do is you follow my arm as I explain the visual symbolic thinking process. You take this x, you say x into x cubed, you get x squared. You write that x squared here. And then x squared times minus 1, you get minus x squared. You take the minus x squared and you put it here. And you subtract minus 3x squared minus x squared. You get minus 2x squared. X into that minus 2x squared, you get minus 2x. Minus 2x times minus 1, you get plus 2x. Take that plus 2x, put it here, and subtract minus 13x minus 2x, you get minus 15x. X into that minus 15x, you get minus 15. Minus 15 times minus 1, you get plus 15. You put that plus 15 here, 15 minus 15, you get a 0. So the terms in the second bracket will be x squared minus 2x minus 15. And you have determined the 2 factors in the first step without having to write many steps. You have straight away determined the 2 factors. In other words, using this symbolic thinking method, it actually reduces the number of steps that you put. After that, you now factorize this, and again applying the same thinking method. The last term is minus 15. Factors of that gives you the middle coefficient. Minus 15, you get minus 5 times positive 3. So you have x and x in the first and second bracket, x and x. Then you have minus 5 and plus 3. So that the factors of f of x will be x minus 1, x minus times x minus 5 times x plus 3. And you obtain these factors in only 2 steps, which is far much shorter when compared to the previous method. This visual symbolic method is not the only method that is used in visualization and symbolization, but because it has got 3 components, all these analytic methods as well as this visual symbolic method, the 4 of them, they all are under the visualization and symbolization approach. So what the approach does is it actually looks at multiple ways of presenting mathematical solutions, which will work to the advantage of the learner, in that when a learner has got multiple ways of solving a mathematical problem, it will become easier for that learner to be able to tackle any mathematical problem that he or she encounters. We are going to discuss an exercise. Exercise 4. There's actually 6 questions. We are not going to discuss all of them, but I'll just show you how the mind of a visual symbolic thinker thinks like when we're looking at these questions. Because the factorization using visual symbolic thinking process is shorter, students can use that to even check their solutions, which they use the analytic methods, to check whether they are correct. And they also, at the disposal of the learner, will be these multiple methods of solving a mathematical problem. If we look at the exercise for question 1, 2, and 3, the question is asking you to factorize each of the following completely. We do have these 3 cubic functions. What happens here is a visualizer or a visual thinker would look at these questions 1, 2, and 3. If you look, you know that to factorize, you would need to look at factors like when you substitute x is equal to either 1, 2, 3, or negative 1, negative 2 into f of x. And when you get a 0, then you get one of the factors. So a visual thinker, when you look at this, if you look at the first question, it's x cubed. All the terms are positive. In the second question, some are positive, while the others are negative. Also, the third one is positive and negative terms. This first question, sorry, you cannot get a 0 if you substitute x is a positive number, because they are all positive. So to get a 0, x has to be a negative number, whereas here x can be positive. There are chances that x is most likely positive. So here x can most likely be positive that you substitute, but here x has to be negative. So instead of having to think the analytic thinking way, students will get lost and start to substitute x is 1, x is 2 before going to the negatives, and then time will be wasted in the process. So I've just shown you how the visual thinker actually quickly gets an effect. Also, here with question 4, they say if x minus 2 is a factor of f of x, find the other 2 factors. Well, it's similar. You can use any of the 4 methods. And question 5, you can also use any of the 4 methods. As well as question 6, right? But you will find that a person who applies the visual symbolic method will quickly get solutions to this exercise. Whereas with the other learner who uses the other analytic methods will take longer because the visual symbolic method has always got shorter number of steps to get the solution. And so that will be that exercise. After the exercise, let us move on to the cubic functions in graphs. Let us discuss that example. Given that f of x is equal to x cubed minus 3x squared minus 9x minus 5, determine the value of f of 0. Determine the x and y intercept of f of x. 5.3, find the coordinates of the turning point of f of x. 5.4, hence sketch the graph of y is equal to 5 of x, indicating where the graph cuts the x and y axis and the coordinates of the turning point. Right. This is a typical examination question of your grade 11 mathematics under the two topics. The solution 5.1, f of 0, you substitute x is 0 in the function. So we are using an analytic method. And you get f of 0 is equal to minus 5. You know, with analytic method, you are substituting x is 0 and then getting minus 5. But a visual symbolic method will look at the function and notice that if x is 0, where there's x, it becomes 0. So can a visual symbolic method would simply from the function say f of 0 is equal to minus 5, because the problem solver will know that where there's x, there's 0. So you get minus 5. So this step is written by an analytic thinking method. Whereas for a visual symbolic method, the answer can be written straight away as f of 0 is equal to minus 5. And this actually also coincides with the y-intercept. 5.2, determine the x and y intercept of f of x. So f of minus 1, when you substitute into the equation and simplify with our calculator, we'll get f of minus 1 is equal to 0, which implies that x plus 1 is a factor of f of x. So we are going to look at that function to get the x-intercept. We take f of x and we equate it to 0. So x cubed minus 3x squared minus 9x minus 5 is equal to 0. So we are applying the visual symbolic method to factorize. So we get that and that, and then therefore conclude when we take each bracket and equal it to 0, x will be equal to minus 1 twice, or x is equal to 5. You know that there is also this understanding that when an x root is repeated twice, when the graph, when it approaches that minus 1, it does not cross, it just touches and then goes back in the same quadrant. So we'll see on the graph how this graph shape will come around this minus 1, which is given as solution minus 1 twice, or 5. Uh, 5.3, to get the coordinates of the turning point, we differentiate f of x. And then we take the derivative and we equate it to 0. Simplifying this quadratic equation by dividing by 3 throughout, we get that. And then we factorize that to get x is equal to 3 or x is equal to minus 1. These are the x coordinates of the turning points of the graph. To get the y coordinate, we substitute each into the function. Our function is f of x is x cubed minus 3x squared minus 9x minus 5. So when x is equal to 3, we'll get our value of y to be equal to f of 3, which is 3 cubed minus 3 times 3 squared minus 9 times 3 minus 5, which is equal to minus 32. And when x is equal to minus 1, y will be equal to minus 1 cubed minus 3 times minus 1 squared minus 9 times minus 1 minus 5, which is equal to 0. Actually, this one we had it previously. So our turning points, the coordinates of our turning points are 3 minus 32 and minus 1, 0. We then move on to the sketching of the graph. And when we are sketching, we are using the visual spatial method. And with this, we're using the information we have found from 5.1 to 5.3. And then we sketch our graph to come out like that. Look at the shape of the graph. Where we're looking at the coordinates of the turning point, we said, so when the x-intercept, we said x is equal to minus 1 twice. The graph does not cross the x-axis at that point. It just touches it, goes back to the same quadrant. And this is the shape of our graph. And you label your graph. F of x is x cubed minus 3x squared minus 9x minus 5. And these are the two coordinates of the turning point. And the x-intercept, which are minus 1 and 5, and the y-intercept, which is minus 5. Exercise 5. Given that f of x is equal to 2x cubed minus 5x squared minus 4x plus 3, first part show that x plus 1 is a factor of f of x. Therefore, factorize f of x completely. Determine the x and y intercept of f of x and the coordinates of the turning points of f of x. Hence, sketch the graph of y is equal to f of x, indicating where the graph cuts the x and y axis and the coordinates of the turning point. Again, in this exercise, we are going to discuss it. But I would ask you, I'm going to ask you two guys from you to volunteer and come and show some of the solution methods. Part 1,3, 1 and 1,4 will most likely use the same method of solution as you saw in the previous example. So part 1.3 and 1.4 will show the same method of solution. But from our previous example, part 1.1 and 1.2, for part 1.1 and 1.2, f of x can be factorized completely using either long division method, inspection method, synthetic method, or the visual symbolic method. As we are all familiar with long division method, I'm going to ask two volunteers from you guys to come forward and present the solutions to 1.1 and 1.2 using the first volunteer will use the inspection method, while the second one will use the synthetic method. And this will be followed by my presentation of the visual symbolic method. Right. So can I have the first volunteer? Yes, Manera, can you come and present the, actually, we will have the first and second volunteers presenting.
I'll be factorizing using inspection method. I'll be factorizing f of x is equal to 2x to the power of 3 minus 5x squared minus 4x plus 3. So the first thing I need to get a factor. To get a factor, I'm going to substitute x is equal to minus 1 where there is x. So if I substitute x is equal to minus 1, I'm going to get f of minus 1 as 0. Therefore, it means x plus 1 is a factor. Then, by checking the expression of my function, I'm going to open two brackets. The first bracket should be my factor, which is x plus 1. As for the second bracket, it's going to be a quadratic expression, but the first value of my second bracket, I'm going to get it by saying which term that I can multiply with x to get x to the power of 3, which is 2x squared. As for the last term, I'm going to say which value do I multiply with 1 to get 3, which is 3. Therefore, the middle term is bx because we don't know b. So I'm going to multiply x multiplied by bx, which is bx squared. I multiply 1 multiplied by 2x squared, which is 2x squared. Then I'm going to add these two terms. The addition of these two terms is equals to this term minus 5x squared in my expression. So I'm going to have the equation as 2x squared plus bx squared equals to minus 5x squared. I see if it's the equation I'm solving for b, then to solve for b, I'm going to take 2x squared to the right hand side. Bx squared is equal to minus 5x squared minus 2x squared. Then the value of b is minus 7. So after getting the value of b, I'm going to substitute back the value of b inside the second bracket where there was b. It means I'm going to put minus 7. So after substituting the value of b, I'm going to have x plus 1, first bracket 2x squared minus 7x plus 3. So then I factorize 2x squared minus 7x plus 3 as 2x minus 1 multiplied by x minus 3. So the factorization is x plus 1, 2x minus 1, x minus 3.
Okay, thank you, Menira. You see the method used, you said it's inspection method. We would like to have another, the next presenter, who is going to present the synthetic method.
Okay.
For factorizing the same problem. Can you explain us through the steps again?
Okay, sir. So we are given a function here, which is 2x cubed minus 5x squared minus 4x plus 3. So we will be using the synthetic method now to factorize. So first we check that f of minus 1, in place of x, we substitute with a negative 1. So now we have 2 into minus 1 cubed minus 5 into minus 1 squared minus 4 multiplied by minus 1 plus 3 gives us a 0. So therefore, x plus 1 is a factor. Now, since x plus 1 is a factor, x will be equal to 1. And then we will write the coefficients of f of x. So we write 2 here, since it is the coefficient of x cubed. We write minus 5 here, since it is the coefficient of x squared. We write minus 4 here, since it is the coefficient of x. And then we write a positive 3, which is the constant there of f of x. Now, under 2, we place a 0, and then we say 2 plus 0 gives us a positive 2. We say this 2 multiplied by this negative 1 gives us a negative 2. And then we say minus 5 plus minus 2 will give us a negative 7. And then we say negative 7 multiplied by negative 1 will give us a positive 7. And then we will say minus 4 plus 7 will give us a positive 3. And then positive 3 times negative 1 will give us a negative 3. And then 3 plus negative 3 will give us a 0. Now, the values that we've got here, which are the coefficients, 2, minus 7, and 3, are the coefficients of a quadratic equation. So this 2 will be my A, this minus 7 will be my B, and this C will be my, this 3 will be my constant, which is C. And then I have my factor there, which is x plus 1 into 2, there, x squared minus 7x plus 3. And then my last step is to factorize this 2x squared minus 7x plus 3. I get x plus 1 into 2x minus 1 and x minus 3.
Okay, thanks, Manera. With that second method, I am going to explain the factorization of the same function using the visual symbolic method. And I would like you to pay attention very, very carefully. The visual symbolic method, how it operates is it encompasses all the previous methods, which are like the synthetic, the inspection, or the log division, and into a simpler form, which actually goes through the mind of the problem solver. So what we have here is, with the first part, f of x is equal to 2x cubed minus, 5x squared minus 4x plus 3. When you substitute f of minus 1 with your x is equal to minus 1, you'll get f of minus 1 is equal to 0, which implies x plus 1 is a factor, which is similar to previous method. When you come to the second part, which is actually the main component of what the visual symbolic method entails, we are having our f of x equal to that. We have found in 1.1 that x plus 1 is a factor. Right? Then, to determine the other bracket, this is how you go through the thinking process. You would say x into 2x cubed, you will get 2x squared. 2x squared times 1, that is 2x squared. You put the 2x squared here. Minus 5x squared minus 2x squared, you get minus 7x squared. X into minus 7x squared, you will get minus 7x. Then negative 7x times 1, you get minus 7x, which you put here. And then you subtract, you say minus 4x minus 7x, which will give you a plus 3x. X into that plus 3x, you will get a plus 3. And 3 times positive 1, you get a plus 3. If you put the plus 3 there, you will have 3 minus 3, you get a 0, which means our other bracket will be equal to that. All these factorization processes are going through the mind of the problem solver. And you are not writing any steps, but the steps are actually occurring in the mind using this method. And then your next step now would be to factorize that quadratic expression. So you have x plus 1, and then here 2x squared, you have 2x and x, and then the factors of 3, that will give you a 7. You want a negative 7x, so a 2x, when you multiply by 3, will give you a 6. And if you are going to put a 1 there, you get an x. So basically, because we need to get minus 7x, the 3 should be a negative, whereas the 1 should be a negative. And then you get your factors as that, which is the answer to your part 2. If you now look at this visual symbolic method, it basically gives you the factorization of f of x in 2 steps. Whereas if you look at the other method, they are a bit longer. So this visualization symbolization method shortens the process or the method in which you determine the factors. And you get the factors in that. And then when you move on to the 1.3, which is the determining the y-intercept, you would need to actually use the usual method, where for x-intercept, you are having your x plus 1, which is the factors 2x minus 1 and x minus 3 equal to 0. Then you will get x is equal to minus 1, 1 over 2 or 3. These are your x-intercept. Right? And then for your y-intercept, you will be in the function substituting your f with 0. Sorry, for your y-intercept, you are substituting x with 0, so that this will become 0, will vanish as well as that. Then you get f of 0 will be equal to 3. So in other words, when x is equal to 0, your f of 0 will be equal to 3, which gives you your y-intercept. And this becomes the answer to 1.2. 1.3 was asking you to determine the coordinates of the turning point. You would then from there differentiate your f of x and equate it to 0 to get the x coordinate. After getting the x coordinate, what you do now is you substitute them back into the function and you get the coordinates of your turning points. After which you then plot your x-intercept and your y-intercept, including your turning points, and at the end of your graph. So what we are trying to portray here in this solution is that there are 3 different methods that you can employ when it comes to the factorization of the function. And the 3 methods are the inspection method, the synthetic method, and the visual symbolic method. And if you look at this, we said the inspection method and synthetic method, both of them are under the analytic methods, while the other method that I've demonstrated is a visual symbolic method. And all these solution methods, they are methods that are used in the visualization and symbolization teaching approach. Thank you so much. Stop there. Right, you guys.